what is the symbol for all real numbers? How does that look? Symbol for all
Isn't
real
a
numbers.
double R?
It's a
Mm-hmm.
R.
Yep, it looks like a little double R like so. All right. So it has a little line attached to the R. All right, let's look at P of X. Now, is this a fraction? Is a fraction involved here?
No.
No.
No. What is involved here? Because we're looking at our restrictions, we only have two things to be concerned about, and this time is this situation right here. We only want numbers that we only want positive values or zero under the radical. Anything else is a problem. So I'm gonna try to write this. Yes, we only want numbers that are greater than or equal to zero under the even root radical. And we say this is even because it's the square root, which is considered to be a 2 here. It's considered to be a 2 here. We don't write it, but it's considered to be a 2 there. All right, I'm going to go to the whiteboard. All right. Just in case it pops up. All right, so P of X equals the square root of X plus 4. For even, so write these notes somewhere. For even root radicals, set what's under the radical to greater than or equal to 0 and solve for the variable. That will give you your domain. All right, tell me for P of X, what's under the radical? Just read it verbatim. What's under the radical right now?
X plus 4.
Hey, Dr. Thomas,
Yes. Zoe, you say something?
are we supposed to see what you writing? Because I don't see it.
Oh, sorry, y'all.
Like, I seen what you wrote in the restrictions, but then I wasn't sure if we were supposed to see, like, what you just said.
Yeah, I want you to see the whiteboard. I forgot you know how sometimes with Zoom you don't have to do all that, but with Collaborate you have to stop sharing and then share another screen. Sometimes Zoom that happens too. All right, I kind of forgot. All right, so X plus 4, we're going to set X plus 4 greater than or equal to 0. So we're solving inequality. It's not too bad. Sort of like solving a regular equation. But sometimes inequalities have strange rules, like if you divide by a negative number, you switch the direction of the inequality. Y'all remember something like that? Those rules with inequalities?
Yes, ma'am.
Yeah. In this case, it's a simple one, so we don't have to deal with it. But I'm just reminding you that if you ever have to divide by a negative number on both sides, you do have to switch your inequality, the direction of it. All right, so we're going to subtract 4 here. X has to be greater than or equal to negative 4. All right. X has to be greater than or equal to negative 4. And let's test it out. Give me a number that's greater than or equal to negative 4. Give me a number. You said negative 2? Negative 3? All right. So here, if we put negative 2 right here, that's negative 2 plus 4. What's negative 2 plus 4?
2.
2. Square root of 2. You'll get the square root of 2. So let me write it like this. If x was equal to negative 2, then we have p of negative 2 equals the square root of negative 2 plus 4, which equals the square root of 2. That's fine, because that's a positive number. What if it was negative 3? If it was negative 3, you would get, if x, it was a negative 3, you would get p of negative 3 equals square root of negative 3 plus 4, which is the square root of 1, which equals what? Square root of 1, which equals
1.
1. That's fine, right? So that's why the domain is all real numbers. Give me a little room here. All real numbers such that, we're switching up the lingo a little bit, such that x has to be greater than or equal to negative 4. Let's choose a number that's not conforming to that. What's a number that is not greater than or equal to negative 4? What's a number that's not greater than negative 5? If we plug in negative 5 into the x, what would happen? If we plug in a negative 5, yes, we get
under the radical.
We get a negative 1 under the radical. Very good. That's a problem because that throws us all the way into the imaginary number system, and we hadn't gotten there yet. You are going to go into the imaginary number system at some point in pre-cal, but we're only in the real number system right now. So like a different planet. We're on Earth right now, and then later on in the semester we're going to go to Mars. That's called the imaginary number system. And then there's a whole nother way of writing solutions. I don't know if y'all ever seen the I that equals the square root of negative 1, but it's coming for you. All right, but we're not there yet. So we do not want numbers that are negative under the radical. So that's why the domain is what can be in x and what is allowed for x. And right now what's allowed is all real numbers such that x is greater than or equal to negative 4. And let me rewrite it different ways. That's how you write it out. Here's another way you write it. Not sure if I told y'all about this form yet. Y'all let me know, because I have another class. I'm not sure if I told you or them. All right, this right here, what notation is that?
Set builder.
Very nice. Set builder notation. All right, so that's when you have the braces involved, and then that line right here means, so this x right here means all real numbers. Well, it's understood as all real numbers such that that vertical line is such that x has to be greater than or equal to negative 4. All right, if I wanted to put this in interval notation, would anyone know how to write this answer in interval notation? Let's do a number line first, just in case. All right, we got a 0 here. We got negative numbers over here. And positive numbers to the right of 0. And so on and so on. Where negative 4 is, should I put an open circle or a closed circle for negative 4?
Or closed.
Yep, a closed circle, or another thing, I normally just put a bracket here. So some people put like a little dot there. I will go ahead and put a bracket because I know it has to be greater than or equal to negative 4. All right, numbers that are greater than or equal to negative 4 are numbers to the right, right? The more you go to the right, the numbers increase, correct? So we go in this direction. We're shading all of this. Okay, we're shading all of this. And we write interval notation from least to greatest. So what number should I start with first in interval notation?
The negative 4.
Correct. And I kind of gave it away. That is a bracket because it's a bracket because of the equal sign. It does include negative 4. If we plug negative 4 in, we get 0 under the radical. A 0 under the radical is perfectly fine because the square root of 0 equals 0. All right, and then we're going all the way to where? To the right. Where is it going all the way to the right?
Infinity.
Positive infinity.
Very nice. So comma infinity. So this notation means everything between, including negative 4, but everything between negative 4 and infinity. That's what that means. All the numbers in between negative 4 and infinity, and including negative 4. Now, if we had a parenthesis by the negative 4, that means it does not include negative 4. All right. Let's move on. We'll have to stop again and go back to our notes. So that's how you treat a radical situation. You'll set what's under the radical to greater than or equal to 0 and solve for x. So I'm just going to put the set builder notation here. It was greater than or equal to negative 4. All right. So either notation will work. All right, but I want you to be familiar with all of them because you never know when you're going to be asked to write it a certain way. All right, f of t equals the cube root of t plus 4. All right, are there any restrictions? And again, as a reminder, restrictions. Either we have a fraction situation, that's the number one, that kind of pertains to number one, or a radical situation. All right, but an even root radical. Do we have either one for f of t? Do we have either situation for f of t?
No.
Do we have a? No, we do not. We do not have a fraction. That's obvious. We do have a radical, but what's different about this radical from p of x?
It's
Cube.
to the third.
It's,
but
yep. It's odd. It's an odd root radical. So we are perfectly fine with having negative numbers under cube roots. For example, what's the cube root of negative 1?
It's just 1.
Cube root of negative 1?
Oh,
It's gonna be negative 1.
Negative 1, because negative 1 times negative 1 times negative 1 is negative 1. All right, so there are no restrictions on this because we are allowed to have negative numbers, positive numbers, and 0. So what's the domain of f of t?
all real numbers, t.
All real numbers. All right, this one, f of s, actually involves both situations. Y'all see the fraction, and you also see the radical, the even root radical. Which one do you want to deal with first? Because we got to deal with both of them. Which one you want to deal with first?
The fraction.
The fraction. So what do we need to do? What do you think we need to do?
Set s minus 4 to 0.
Very nice. All right. Let me stop sharing. I need to go to the whiteboard. I need room for this one. All right. So since we have s minus 4 denominator, we do not want that denominator ended up equaling 0. So what we need to do is figure out what number will make it 0. Now you can obviously look at it and tell what number will make it 0, but we're going to work it all out. All right. So let's see. It's f of s equals the square root of s minus 1. S minus 4. All right. So you said, let's go with the denominator first. We'll do that. Let's do that first. All right. Look at the denominator. S minus 4, we don't want it to equal 0, so we're just going to figure out what makes it 0. We're going to add 4 to both sides. So S equals 4. S is the number we don't want, right? I put a line through it. We don't want S to equals 4 because that'll be an issue. But let's look at this radical situation. radical. What do we need to do to deal with or treat this radical? We just went over one example. What do we need to do for this one to figure out what S is allowed to be under the radical?
You got to set it greater than or equal to 0.
Very nice. Very nice. We're going to set S minus 1 greater than or equal to 0. All right, we're going to add 1 to both sides. So S can be greater than or equal to 1. So we got to some kind of way combine these two situations as one answer. All right. Now let's look at a number line so we can really figure it out. On one hand, we're saying that S cannot equal 4. So are we going to put an open circle or a closed circle at 4? We're saying it cannot.
Open.
We're saying we're going to be open because we don't want it to equal 4. Now, if we bubbled it in, then that means that we want it to equal 4. All right. And also, so we took care of that. We got an open circle on the number line. But the other side is saying S has to be greater than or equal to 1. So what would you put at 1 to indicate that? And this is 1 right here. What would you write there or
Just
draw or
bracket.
put a bracket? All right, since it said greater than, we're going this direction. All these numbers here are greater than 1, correct? But I can't go through 4 because we already said that's a restriction. We kind of have to skip over 4 because if we plug in 4 into this function, that's going to be a problem. The denominator will end up being 0, which makes it undefined. So how would I write this answer? So what is the domain of the function? Looking at your number line, how would you write it? And let's do interval notation. What would you write first?
Bracket. You write a bracket.
Bracket 1.
Bracket 1, nice. Bracket 1. We're going
4.
all the way.
4.
Yep, we at 4. Yep.
It's gonna be a
very
parentheses.
Nice. Very nice.
Close parentheses.
Yep. So we got to skip over to 4, but we still got a ways to go. How do we? I don't know. Connect some stuff. What else we got?
You got to put the union sign.
Yes, that union is how we. Oh, okay. I did that. The union is how we kind of connect that piece plus that piece. So that's called union. All right. And where do we start after the union?
Would it be 4 to infinity? 4 to infinity.
4 comma.
It's gonna be you're gonna put bracket and then a close parentheses.
Do I want to include 4? Do I want to include 4?
No, you're gonna put a parentheses.
Parentheses on both sides.
And then parentheses on both of them.
Yes. Yeah. Anytime you have infinity, negative infinity or positive, you always use a parenthesis because you can't really reach infinity, right? You're going towards, but you're not going to touch infinity. All right, so you can't really include infinity. All right, good. All right, we are done with domain. All right, so you should be able to complete problems on domain right now. All right, but you can always ask questions on Thursday about the domain part. We're going to move on. All right, let's get to the easy domain and range. That's when you find the domain and range of a relation. A relation is just a set of points. Y'all remember coordinate points. All right, consider the relation 1, 5, 2, 8, 3, 11, and 4, 14. Right in here. The domain is just the x values. What are the x values?
1, 2, 3, 4.
The only thing is we have to put these little braces around it. All right, you just have to put braces around it. Similarly with range, you have to put braces around it. The range, just the y values. What is the range of this relation?
5, 8, 11, and 14.
Yep. Done. That's the easy domain and range. All right. Another question you will be asked is the relation a function? The relation is a function if no two-ordered pair have the same first component. That sounds so weird, but all it really means is every x value has to have only one unique y value. If it has more than one value for that one y for that one x, then it's not a function. Look at this example. Consider the relation 2, 1, negative 2, 3, 2, 5, and 6, 3. Do all x values have only one y?
No.
Uh-oh, baby.
No.
No. Tell me, explain, what do you see? What x value has more than one y?
The negative 2 and 3 and a 6 and 3.
Which x value has more than one y?
2, 1,
Which
and 5.
All right. So this one and this one, because 2, that one x is going to not only 1, but it's also going to 5. That's a problem. All right. It only needs to go to one x value. It's going to two different, only go to one y value. It's going to two y values right now. So no, it is not a function. Since the x value 2 is going, I can just say has more than one y or something like that. All right. So you want, when you do one thing, that when you have one input, you only get one result. You don't want to have more than one result. Something as simple as, and I might put that, I have a recording that I did years ago about a situation. It's sort of like if you are a student in a class, which you are, how many grades are you going to end up having as your final grade?
Only one.
Only one. Does it make sense for you to end up having two different grades in this class?
No.
Or you got an A and you got a B? That doesn't make sense. Or you got an A and you got a C? That's not something like that doesn't make sense. You only want one for the X student and then Y grade. You should only have one grade. You shouldn't have more than one. All right. So, or if you go to, I don't know, I'm just making stuff up, right? And I use post office example a lot. If you have a package, you go to the post office, they weigh that package. It's a certain weight. Once they put it on the machine, you should only get one Y. You should only get one result of how much that costs. Now, if they give you 2 or 3 different costs, something's not right for that one weight. All right. So that's an example of what's functioning correctly if you have one output to that one X or input. All right, let's look at B. This one is in, just put it in different forms. This is a table. Even in the table, you should be able to see, is it a function for B or not?
No.
Right. You see that 2 is going to 11 and 2 is going to 10. That same 2 is going to 2 different Y's. That's not a function. Okay, so no. All right, let's look at C over here. May not can be able to tell right off, but let's just write down what are the points. Tell me, what is this point right here?
2, 3.
2, 3.
2, 3. What is this point right here?
1, 0.
1, 0. What about this one?
Negative. No, 0, negative 1.
0, negative 1. What about this one?
Negative 1, 0.
Negative 1, 0. And what about this one?
Negative 2, 3.
Negative 2, 3. Now, a good sign is we don't have the same x occurring. That's a good sign. So is the function or not? Yes or no? Function? Yes or no?
Yes.
Yes. Yes. Nothing. We don't have that same x going to two different y's. And we're going to talk about the vertical line test and everything maybe on Thursday. But for now, that's one way you can tell if it's a function or not. All right. On your homework, you're going to be asked a question like this. Find all real values of x such that f of x equals 0. Sounds very complicated. It's not. All right. All it's really saying is solve for x. All right. Solve for x when f of x equals 0. So let's look at A. Let's look at this one first. What does f of x equal in A? If you look just at A, what does f of x equal?
Would it be 0?
Just read it off verbatim. And for A, what does f of x equal? 15 minus 3x. All right, let me stop well, I can write it over here. I can write it. All right. So according to this is what we're looking at. F of x equals 0. All right. So all it's saying is set f of x to equal 0.
So
All right. What is f of x? You just told me.
15 minus 3x.
15 minus 3x. All I'm doing is replacing f of x with what is equal in A. 15 minus 3x. And all I'm going to do now is solve for x. That's all I'm doing. It's as simple as that. I'm setting what f of x is equal to 0. That's all I'm doing. So again, I'm just making a substitution for f of x. All right. How do we solve for x? We have 15 minus 3x equals 0. What would you do to get x by itself? All right. You'll subtract 15. I don't know. I would have probably just added 3x. But since y'all said subtract 15, we're going to do that. That cancels. Negative 3x equals what on the right side?
Negative 15.
Negative 15.
Negative 15. And then do what?
You want to
Divide.
Divide by negative 3 on each side.
Nice. Cancels. And then x equals
5.
5. Done with A. All we're doing is setting the f of x to 0 and solving for x. That's all we're doing. It sounds fancier than that, but that's all we're doing for these. Any questions about A? All right. B. Again, all of these A, B, C, and D. Same thing we're doing. What are you going to do for B then, based on what we did for A? What would you write down first?
3x minus 4 over 5 equals 0.
Oh, you want to C. Go to B.
Oh, my bad. X squared minus 9 equals 0.
Nice. We're just setting x squared minus 9 to equal 0. That's all we're doing. Again, we just switching out f of x to what it's equal to in B. What would you do next? Someone else.
You'll add 9 to each side.
All right. I usually recommend something else. Anybody else? Well, adding 9 will work too. Factor. Yes. Anybody know why I would rather y'all factor than adding 9? You may not know.
Squared. So you won't get it
Yeah.
confused when you have to square it.
Yeah, because a lot of times when y'all add 9, y'all forget there are 2 answers, right? There are 2 answers to this problem. When you factor it, you can see the 2 factors. All right, so we set each factor to 0, and we get x plus 3. We'll just go ahead and give the answer. X equals -3. X equals +3. Now, you were right when you said, this is the alternative. Add 9. Add 9. That works too. What would you have to do at this point?
You'll have to get the square root.
You do the square root. And then what can't you forget though?
You got to put the plus and the minus with the 3.
You got to put the plus minus. So those are 2 different answers. 2 answers will work. Because -3, if I plug -3 into this x, -3 squared would be 9 minus 9. It solves the equation. And if I plug in +3, 3 squared is 9 minus 9. Also is equal to 0. So both work.
Miss Thomas.
2, yes.
Oh, sorry for interrupting. That same question was on the homework, and I had I got the answer 3, because I was looking up YouTube videos. But putting that little sign right there, the plus over negative sign, it was hard to put it in there to get the right answer. That makes sense.
Right. The
Because it
answer
tell
is
you to put it in there as a
-3.
comma.
Yeah.
Okay.
+3.
Okay.
So -3, +3.
Okay.
Yeah, you put that in the box, right? So in Weber sign, let me just say this: there is never a plus minus symbol. You have to write all the answers out individually. There's no a shortcut way. I know y'all don't want to write everything out and all that. Y'all trying to come up with a concise way to write it. They want you to write every answer separated by a comma. All right. Any other questions about B? All right. Well, someone else explain how would you set up C? What would you write first for C?
(3x minus 4 over 5 equals 0?
3x minus 4 over 5 equals 0. All right, whenever we're dealing with fractions, or as they call it, rational equations, how can we get rid of these fractions first so we don't have to deal with it? How can we get rid of this fraction?
Still multiply 5 on this.
By multiplying
Very
the
nice.
denominator.
Multiply by 5. Very nice. That 5 will cancel out with that 5. Then you have 3x minus 4 equals 0. Got rid of the fraction. That's what we want. All right. And then we just solve for x by doing what?
You add 4.
Add 4. Then that cancel. We get 3x equals 4. Then
You divide by 3.
divide by 3. 3's cancel, or same thing as 1. We just don't write it. X equals 4/3. Done. Any questions about C?
If that question was on WebDesign, would they want us to put it 4/3 or like 1 1/3? Or do you
I'd
not know?
rather you just put 4/3.
Okay.
Yep. I always just make it, I always just keep it as the improper fraction. Don't change it to a mixed number. All right. D. Can someone else explain how do I set up D?
You'll do x to the 3rd minus x equals 0.
Very nice.
And then I think you're gonna factor.
You're going
You
to
might
Yes.
factor it out. Factor out
All
x.
right.
And x squared.
X squared
Yes, minus.
minus
1.
1. Very nice. Someone other than Alicia and Zoe, what would be the next step?
Factor it again.
All right. Where would you factor, Nakiria?
The x squared minus 1.
Very nice. Very nice. All right. Someone tell me, other than Nakiria, Alicia, and Zoe, what would be the factors of x squared minus 1? What would be the factors of them? Other than the Nakira. I saw you, Nakira. I had to catch you. No, Nakira, no. Someone other than Nakira, Zoe, and Alicia. All right, Kenyatta, what you have to say?
X plus 1, X minus 1.
Very nice. All right, X plus, that's what call a difference of squares. So yes. All right. Someone other than Kenyatta, Nakira, Zoe, and Alicia, tell me, what would you do next?
You set everything to 0.
Set everything to 0. So tell me what to write when you say that.
So I mean, this is already the way it is. You can just do like X minus 1 and X plus 1. And then don't you have to set the other X to 0 also? Because you have to have 3.
Yeah. Don't ignore that. It's 3 factors, right? The first factor is X. All right, I'm gonna put OR. We like the OR in math. X plus 1 equals 0, or X minus 1 equals 0. So we just don't have to solve it because it's already done for us. All right, and we do have -1, and we do have +1. Find all real values of X such that f of X equals g of X. What do you think they're asking us to do? This is different from this one.
You gonna set f of X to g of X, like
exactly.
You gonna put x squared equals X plus 2.
Very nice. All right, we're doing exactly what they're saying. So I'm gonna write it. It says set f of X. We know that f of X equals X squared. If they told us what f of X was, that's right here, right? And then, see, can I switch colors right quick? All right, and then we're gonna put down g of X. That's right here, X plus 2. We're gonna set them equal each other and solve. All right. So what would you do next, someone other than Zoe? You have X squared equals X plus 2. How would you approach solving that?
I will move everything to the left and
Very nice. Very nice, Alicia. Move everything to the left side. So put everything on one side. All right, put everything on one side. On one side. And because X squared is positive, I'm going to move everything to the left because I don't want to make X squared negative. All right, so we're going to move -X, and we're going to move -2, well, 2 by subtracting 2. So what we have now is X squared on the left side, a -X, and a -2 equal 0. So we subtracted X from both sides, and we subtracted 2 so that everything will fall on the left side. Someone other than Zoe and Alicia, what would you do next?
Would you find what numbers multiply to give you -2 and add to give you -1?
Very nice. So what we call that math concept? We are about
factoring.
to yes, factor is the next step. This is the easy case. I call it the easy case because this is an X. It's 1X here, 1X squared. So it's just gonna be 2 parentheses, right? X and X. It can't be anything else but X times X is X squared. So that's why I call this the easy case. Can someone tell me what factors of -2 will add to -1 other than Christina, Alicia, and Zoe?
-2, X minus 2, and X plus 1.
Yes, -2 plus 1. Very nice. -2 times 1 is -2. -2 plus 1 will give us that -1 in the middle. All right. Someone other than Alicia, Christina, Kenneth, and Zoe. Yes, Monisha.
The X in the middle, did it just we didn't solve for it?
The X in the middle?
Yes, ma'am.
Ask the question again. What about the X in the middle?
So we did the factor for the X squared. What about the X in the middle? Does it not need to be factored or what?
All right. So when you FOIL this, you'll see. All right, so when you fold this, you get x times x, which is x squared, x times 1, which is 1x. You don't have to write 1. I'm just writing it to emphasize it. Negative 2x. Negative 2 times 1 is negative 2. That's your middle right there, right? Those are like terms.
Gotcha.
What is 1x minus 2x? That's negative 1x. We don't write the 1 though, right? We don't write it. It's customary
ma'am.
not to write 1 as a coefficient or exponent. So yeah, that's just a trick to factoring. That middle is taken care of just as long as you do the AC method, which is just multiplying, figuring out what numbers will multiply to give you negative 2 and add to give you negative 1. That middle will take care of itself if you just follow that little trick. All right, next step. What did you say? Somebody said something. All right, what's the next step? What's the next step?
Set them both to 0.
Yes, Mary said set each factor to 0. And then we're going to go ahead and solve. I want to add 2, subtract 1. So x equals 2 and x equals negative 1. All right. Questions about that? Okay. Let me, anytime you see, if I ever make a mistake, let me know. Sometimes I'm writing something and then I'm thinking about it the next step. All right. B. F of x equals the square root of x minus 4 and g of x equals 2 minus x. We're still following the same instructions here. Find all real values of x such that f of x equals g of x. Same thing. Someone other than Zoe, tell me what to write first.
You're right. Square root of x minus 4 equals to 2 minus x.
Nice. Square root of x minus 4. I don't know why I'm writing all in the middle. I need room for this one. Square root of x minus 4 equals 2 minus x. This is called a radical equation. Maybe you remember it from Math 100. All right. If you remember it from Math 100, what should you do next? It's a different type of equation here. This is not a trinomial equation where we pull everything to the left side. This is different. Anybody know what you should do?
Would
Do
you
you
better
square
do
it?
greater than equal to?
You said both equal to 0?
Because they're still equal to each other.
Want to work on the radical?
Combine like
something.
terms?
Do you square it?
These are all good guesses. These are all good guesses. The right answer is isolate the radical. What does isolate mean? What do I mean by isolate the radical?
Get the radical by itself.
Make it by itself.
Yes, get the radical by itself. Get the radical by itself. So in one move, I can get the radical by itself. So what chess move I need to make to get the
Add
radical?
4 to the right.
Yes, add 4 to both sides. All right. So we have square root of x equals now, because that canceled. What on the right side?
6 minus x.
Yes. All right. That was the first step when you have radical equations. Anybody know the second step? Because I got a radical in my problem. How am I going to get
You
rid
have
of
to
that?
get rid of the radical. You can square it on both
Yes.
sides.
Yes. Square both sides. That's how we get rid of it. Square both sides. Now, if it was the cube root of x, what would you have done? This is square root of x.
So you would have just
squared it.
So you have to get the
You would have just
cube.
cubed it. You would have cubed both sides. Yep. Yeah, that will go off to be a little bit more complicated. But glad we got a square root of x this time. So the radical, square root, and squaring are inverses of each other. Because they're inverses of each other, it cancels out the radical. on the left side. The radical goes away. All right. So they are, again, inverses of each other. But on the right side, what does this mean? 6 minus x squared. What does that mean? What do I have to do with that?
Don't you like multiply it?
Okay, what do you mean multiply?
You
Like
have to
6
write.
minus x times 6 minus x.
Very nice. Who said? Which one of y'all said that? All your mics are on. Who said that? Nakiria, Ashley, or Christina?
It was me. Nakiria.
Ashley. Okay, Nakiria. Very nice. Yeah, because we're squaring it on this side. So this is a binomial square. Anytime you have a binomial square, you write it twice. Write it twice. There's no shortcut method for this. Sometimes people like to do the shortcut method because they think it's 6x squared. Now 6x squared, you can do the shortcut method because it's multiplication on the inside. But if it's a plus or minus sign on the inside, you have to write it all out twice. All right. Then what happens on the right side? What do we need to do?
Multiply.
Don't say cross. You just need to simply multiply, right? Or what's a acronym? Yeah, the acronym for. Yeah, we like the acronym for in math for some reason. But really, we just doing distributive property or just simply multiplying these two together. 6 times 6 will give us the 36. 6 times negative x, negative 6x. Then negative x times 6, negative 6x. And negative x times negative x is positive x squared. So just rewrite x on the left side. On the right side, we have 36. What would you write next?
Minus 12x.
Minus 12x plus x squared. All right, as y'all can see, this is no longer a problem. So I'm gonna erase this part. Go to the right over here. Anybody, what would you do next? Don't we have a trinomial?
Back of that problem.
All right, what's the first step before we do all that? We can't do it just yet.
You gotta rewrite it. So you'll have to put x squared minus 12x plus 36.
All right, well, I'll rewrite it. It's not necessary that you rewrite it, but I do want to put it in descending order. All right, it's not necessary that you could have done it just now, but what the crucial step is to do what next?
To find the factor.
Because I have an x on this side, y'all. I can't factor anything just yet.
You'll have to move the x over to the right and equal it to 0. And then you'll combine.
You said moved? Yes. So again, remember, see how we had this trinomial, and what we say we do? Put everything on one side. Anytime you see a trinomial equation or a quadratic equation, some people call it, you have to put everything on one side first. So put everything on one side, and the easiest way to do it on this one is just subtract x. Subtract x from both sides. Then you have 0 on the left side equals x squared. What would be next? Somebody other than Alicia. What would be next?
13x.
What did you say, Christina?
I said minus 13x.
Very nice, Christina. Minus 13x plus 36. Because these are like terms. We have to combine negative 12x minus 1x to give you negative 13x. All right. Someone other than Alicia and Christina. Tell me, what happens next? What happens?
Couldn't you use the quadratic formula?
You could, but I think what's easier than that if we can do it? What's easier than that? Factor. Yes, Nakira, you can use a quadratic formula. I just think factoring, if it's factorable, is easier. All right. Now again, this is an easy case, so I already know it's gonna be x times x. There's nothing to debate over that. Okay, but I need to know factors of 36 that add to negative 13. Somebody other than Kenneth, other than Alicia, Christina, Nakiria. What are two factors if I multiply them? Of course, that's what factors mean. You multiply, you get 36. But if you added the two factors, you get negative 13.
-9, -4.
Very nice, Justin. Very nice. -9, -4. -9 times -4 is positive 36. -9 plus a -4 is -13. Now, you probably already guessed it. We set each factor to 0 and solve for x. So x equals 9 or x equals 4. You would think we were done, but we're not. You must check all potential solutions of radical equations. All right, you must check all potential solutions. So we don't know if these are truly solutions right now. So I'm going to go to the whiteboard and we're going to check x equals 9. We're going to plug 9 in to the original equation to see if the left-hand side equals the right-hand side. Y'all might have to tell me what the equation is as I go to my whiteboard over here. All right. It was the square root of x minus, was it 4? Equals 2 minus x. Was that the original equation?
Correct.
All right. So check when x equals 9. Let me show you how it's done. All we're doing is replacing. Okay, let me put this right here. All we're doing is replacing all of the x's with 9. So I'm going to leave it blank for a second and change colors on y'all. 9 goes here, 9 goes here. I'm checking to see, does the left-hand side equal the right-hand side? So you don't need to move things over. You do not move anything over when you're checking. We're just trying to see, does the left side equals the right side? That's all we're trying to see. What is the square root of 9?
3.
Yep, 3 minus 4. What is 2 minus 9 over here? 2 minus 9.
7.
-7.
-7. What's 3 minus 4? You already see this not right. What's 3
-7.
minus 4? Negative
-7.
8 or 1.
3 minus 4. Negative 1, right?
8 or 1.
Does -1 equal -7?
No.
Of course not. So therefore, we know 9 is not the solution to this problem. 9 is not the solution to this problem. I want you to check when x equals, what did we say the other answer? Potential answer was? 4. 4. I want you to check when x equals 4. And I want you to direct message me if it's a solution or not. Yes, is it a solution or not? Direct message me, so private. Don't share it to everybody. I just want to see, can y'all do it? Is 4 a solution to the same problem? So check when x equals 4. Okay, somebody sent me something. Let me see. All right, all you have to do is say yes or no. Okay, okay, okay. Yep, this gives me feedback so I know how to approach the problem. All right, good. Thank y'all for responding. All right. All right, so I'm gonna explain it. I'm going to explain it. All right, so again, the original equation is the square root of something minus 4 equals 2 minus something. So I'm going to switch out the x's with a 4, like so. So I'm replacing all the x's. What's the square root of 4? What's the square root of 4?
2.
2 minus 4 equals 2 minus 4. So already I can see it equals each other because it's 2 minus 4 does equal 2 minus 4. Both sides, the left-hand side equals the right-hand side. Therefore, what can we conclude about x equals 4? X equals 4 or 4 is
The solution?
the solution.
What's
Yep.
the solution?
4 is the solution. Is 9 the solution to this problem as well?
No.
No.
Because each side on each.
No.
Right. So this particular problem there was only one solution. What if 4 wasn't even a solution? What would you have concluded?
No
The answer wrong.
solution.
No solution. There's just
no solution.
no solution. There's just no solution. Since we're solving an equation, we'll just say no solution. All right, let's do this application problem, and then we'll be done for today. The path of a baseball. A batter hits a baseball at a point 3 feet above ground at a velocity of 100 feet per second and an angle of 45 degrees. The path of the baseball is given by the function. So it's nothing we need to do with all this. They're just saying this information, someone already gave us the function for that information. And let me point this out too. I changed the note. So if you printed these notes out really early, then they changed. I think I switched out the application problem for this problem because I have noticed I had a lot of baseball players in my Math 112 class, so I switched it out. Ms. Kyria, do you have a question?
That's what I was going to ask you because I had already printed them out ahead of time.
Yeah, sorry, Ms. Kyria. I was like, let me update these so to fit you all. I might start putting some business questions in here because all y'all want kind of side hustle for some reason. All right, so the function is f of x equals negative 0.0032x squared plus x plus 3. That's our function, where f of x is the height of the baseball. What is f of x? I'm just asking you to repeat stuff. What is f of x?
The height of the baseball.
Very nice. F of x is the height. So usually what we really want to know, what is x and what is y, okay? Height of the baseball, and as y'all learned already, f of x is the same thing as y. All right, and x is the horizontal distance from home plate in feet. What is x? What is x?
300. I don't mean no.
You already skipped the horizontal distance from home plate. Yeah, that's all I wanted. You already read the question. All right, good though. All right, so x is the horizontal distance. Horizontal distance from home plate. All right. Question is, will the baseball clear a 10-foot fence located 300 feet from home plate? So we gotta let's just say this is home plate. You're the baseball player. All right. And then the ball is going to go in this direction. And the reason why we do a lot of quadratics, notice it's a parabola. That's why we do a lot of quadratics, because a lot of natural phenomena follows this pattern of going up and then gravity hits it and it goes down. So let's say there's a fence right here. This is the fence. We want to know, will it clear it? All right, so we're about to see. All we need to do is plug in X. All right, and I think someone already told us what X was. What is X according to this question? Will the baseball clear a 10-foot fence located 300 feet from home plate? Which number represents the X? Because the X is the horizontal distance from home plate. Which number represents X?
300, right?
300. All right. So all we're going to do is evaluate the function at 300. So looking at the function, f of 300 equals negative 0.0032 times 300 squared plus 300 plus 3. All we're doing is plugging in 300. Can someone tell me what is 300 squared?
90,000.
90,000. Now put all this in the calculator and tell me what the final answer is, because I gotta let you go. Put all of the right in the calculator. Make sure you put that negative sign in there. What do you get on the right side?
15.
15 feet. Did it clear the 10-foot fence? Yes.
Yes, ma'am.
All right. That's all, folks, for today.